Hi guys, your favourite armoured penguin again. So, today in Common Flat Earth Misconceptions Part 3, we'll be talking about the scientific method and the zetetic method. I'll give you a quick background on the zetetic method first. Originally proposed by Samuel Rowbotham, the zetetic method is it's noble in its original idea, however, it is fundamentally flawed when compared to the scientific method. The most basic way of explaining the zetetic method is that if you start with a premise based on an observation, the simplest premise you can come up with, from that point on you explain your observations without breaking what is already known. So new ideas must not contradict anything that you've already known. This means that instead of wiping out things in favour of a new theory, you make that theory fit the old one. So if you start with an observation, you draw the simplest conclusion, and then for every further observation you draw the simplest conclusion that does not contradict previous knowledge. A lot of you will know what the scientific method is, but basically you start with an observation, make a hypothesis that would explain that observation, and then you test the hypothesis. You test this hypothesis by making predictions, and if it can match those predictions, then you can confirm that that theory fits. If your theory adds detail or completely rewrites existing knowledge, then that existing knowledge is dropped in favour of the new one. So practically, what difference does it make? What we're going to do is we're going to go through three observations, okay? And these three observations are observations you can make today about the Earth. And we are going to treat them in the scientific method, and then we're going to treat them in the zetetic method. But we're not only going to treat it with the zetetic method, but we're going to do it twice. I'm going to show you two different ways of doing it with the zetetic method. So, if we start with the scientific method, we can go with the horizon looks flat. The only conclusion we can make from that is that the Earth looks flat. That's it. We could come to the conclusion that because of that it's probably flat, but we can't say for certain. The sun dips below the horizon is our second observation. So, the sun is probably going under the Earth because it dips below the horizon. The third observation is that time zones exist and sunrise and sunset change depending on your longitude. So the conclusion that we can come to there is that the sun is probably passing overhead in these zones at different times. Because this doesn't work with the two above theories at the same time, they must therefore be bunk. For the sun to go under the Earth, and whilst under the Earth still be lighting different time zones, then the Earth must curve with the sun. It must also be large enough that it looks flat to the naked eye. We've basically come to the conclusion that the Earth is round, because the sun goes under the Earth, but it's under different parts of the Earth based on the time of day. Now, if we rearrange those three observations and read them out in a different way, let's see if we can come to the same conclusion. So, we'll start with the same place. The horizon looks flat. So the Earth looks flat, is probably flat. Number 2, time zones exist and sunrise and sunset change on your longitude. So the sun must be passing these areas at different times. 3, the sun dips below the horizon. The sun, and therefore the Earth, curve around, allowing the different time zones and daylight at different times, with the sun dropping below the horizon at different times. The Earth must also be large enough to make the Earth look flat for the naked eye. So you can see when we take those three simple observations, using the scientific method, regardless of how we look at them, we come up with the same conclusion. Now, what about with the zetetic method? So, the horizon looks flat. We have to come up with the simplest explanation for that. So the Earth is flat. Looks flat, is flat. Simple. Second, the sun dips below the horizon. Well, the simplest explanation for that is that the sun goes under the Earth's disk. That's the simplest explanation. 3, time zones exist and sunrise and sunset change on your longitude. Now we come into a rather interesting problem, because obviously the Earth is flat. We established that in observation 1. And the sun dips below the horizon. We established that in observation 2. That gives us a few troubles when it comes to time zones. and the sunrise and sunset happening at different times on different parts of the planet. So something has to be causing the light of the sun to reach parts of the Earth at different times. At this point, your general flat earther will step in and say perspective. But perspective doesn't work like that. Anyway, so we'll ignore that, because we've got a bit of a difficult time trying to explain what it is that's causing the light of the sun to reach parts of Earth at different times. So let's go ahead and do it again, but using the second order of observations that we use for the scientific method. Now remember, the scientific method came up with the exact same theory, or the exact same idea, regardless of how we read those observations out. So we'll start in the same place again. The horizon looks flat, so the Earth is flat. Observation 2, time zones exist, and sunrise and sunset change on your longitude. Therefore, the sun passes these areas at different times of the day. 3, the sun dips below the horizon. Some unknown phenomena has to cause the sun to appear to drop below the horizon, because we know if the Earth is flat and sunrise and sunset change the time based on where on Earth you are, we know that the sun can't go underneath the disk anymore. So you see here that the zetetic method, whilst, as I say, whilst seemingly honourable in its ideas, breaks down quite quickly once you start adding more and more observations to it. And trust me, we've just dealt with 3. If we add 4, 5, 6, or even, as it actually turns out, hundreds or even thousands of observations to this, it gets worse and worse. However, the zetetic method is quite fundamental in how flat earthers think. They start with the one premise: it looks flat, so it is flat. So, yeah, we can clearly see here that the zetetic method, because you can't contradict previous conclusions, has to invent phenomena that attempt to deal with the observations that do contradict with previous knowledge. It does also mean that whatever observations are made, there is a previous conclusion that has to be held as dogma. You cannot change that previous observation, because that's it. That's the observation you made first. That's your previous knowledge, and you cannot contradict that. So I'm sure you can all see that fundamentally the zetetic method is flawed, and the scientific method, again, proves that, while not being perfect, it's certainly the best we've got at the moment. Alright guys, well, thanks for listening, and I will catch you again soon. Cheers.